Hi, I'm Zane. I run the different security teams at Etsy. I've spent most of my career more on the offensive side, so a long time consulting at AppSec partners. In fact, depending on whether you want to believe this guy up front or myself, one of us was either the first employee or the second employee at AppSec partners. Totally first, don't believe a word that guy says. Yeah, that's pretty much background. I want to give a shout out to everybody on the team and everyone that made this whole talk possible. In fact, Mr. Ken Lee right there in the audience is one of them, and he's giving a talk tomorrow on the CSP panel. And it's awesome, and you should go check it out. And then also a shout out to all the other organizations that we've really enjoyed collaborating with. And the whole point of this is, one, to give a shout out to them because we've really enjoyed cross-team collaboration. But the other thing is just as almost a takeaway here of reach out to your peers. Like, everyone wants to talk about what they're doing and the techniques, like the lessons learned that we've done in defense. And the more that we're all talking as as organizations, the better. Excuse me, the better. So the first question I usually get after that thing of like where I'm at is, cool, what the hell is Etsy? And so we'll just screenshot it out. It's like an online marketplace for handmade and vintage and pure irony. It's fantastic, which then immediately gets followed by, depending on how much beer people have had, which is like Etsy security, why? And the thing is, everyone has things to protect, and there are things that are after all of us. And, security's interesting. So don't worry, the jokes are only going to get worse from here on out. So just like as much chuckling as you want to do now, that's it. So this whole talk is about shifting the way that we approach defense. And it's about historically the fact that we've really taken a very uncontextualized approach to defense as organizations. And what we need to be doing is rethinking the way that we're going about that and rethinking the way that we're approaching defense and shifting to building around real world patterns of attack and patterns of compromise. So that's cool. Those were nice big words. What the hell do I actually mean by uncontextualized? Historically, what we've done as organizations is we've really kind of three high-level things I see. We've focused on this concept of a perimeter, never mind that hasn't really existed for a long time. We've deployed products that don't address how people are actually getting compromised, real patterns of attack, and how all these incidents that we read about are actually happening. And then finally, we've kind of we've so overloaded the term pen testing at this point that we've treated one very small subset of pen testing as a very wide encompassing thing. And the problem with all of these is that they don't address how we're actually all getting compromised. So cool, what should we be doing? It's very easy to stand up here and say we're doing everything wrong and then be like, cool, now it's your problem, and walk off stage. Hopefully this is about what we should be doing. So fundamentally, we have three real goals here. We want to be raising costs to attackers. We want to increase the cost of compromise. And you notice I don't say prevent. Prevention, I could go into a long tangent there, but prevention isn't really something that I'd say is very feasible. What is feasible is increasing the cost of compromise. Hopefully coupling that with increasing the odds of detecting compromise and sooner in the cycle, and then iterate off of real attack patterns via simulating data and via looking at data of other compromises and iterating our defensive posture based on that. So I'm going to talk about all three of this is kind of the agenda for the talk. I'm going to talk about detecting compromise first, then go into kind of raising cost and reducing attack surface and what are some practical organizational things you can do there. And then finally, how do you run simulations, attack simulations, to be able to get the data to actually iterate your defenses? So first section up is detection. Okay, and this is kind of the whole theme of the talk, but I just wanted to iterate it up front again, which is thinking about how to build your, oh yeah, I should probably quit my demo software before giving a talk. Hi, I'm a professional speaker. It's nice to meet. Building your defenses from an offensive mindset. And that's really what a lot of this boils down to. So I'm going to give some examples of different areas of the attack chain and different areas that you can do instrumentation here with some kind of practical examples. And I'm going to focus on initial compromise and persistence in C2 and lateral movement and all that. So let's jump into initial compromise. And kind of the soundbite of this almost is, how can you instrument your endpoints to really detect compromise, or how can you rootkit your endpoints before your attackers do? And one of the interesting things that we've learned, like one of the biggest takeaways we've learned out of doing this across our environment, is really focusing on behaviors and system command execution and things like that. How can you instrument your endpoints to detect anomalies and patterns of compromise? So one of the most interesting things that we've learned out of this is logging command execution and then starting to analyze this data. And what you do is you take a look at that data, and then you start to build patterns of alerts from different kind of categories of anomalies. So what do I mean when I say anomalies? Stepping back and looking at it organizationally, the most effective way that we found to do this is bucketing the entire organization into technical and non-technical. And then you start to apply patterns based off of that. So you start to look at, okay, what is anomalous for a non-technical user? What is anomalous for a technical user? And then what is just always anomalous across your organization? For non-technical, it's very easy, actually. You look at any sort of commands that indicate technical knowledge for your non-technical bucket. And how this actually plays out in practice is it's either an attacker or your IT team. Somebody is technical and using that system. But it's very easy, and I'll give you some kind of, I don't go down into the details too much here, but like as practical examples on this, if your customer support laptop, your customer support agent on a non-technical laptop is running netstat, that's anomalous. Not saying it's bad, but it's anomalous. And that's why you see why I say anomalies so much and never, malicious actions and things like that is malicious actions are a subset of anomalies. And if you can get your anomalies where they're unique enough, then you can actually invest the time in investigating those things when they go off. So when netstat executes on your customer support laptop, it's not guaranteed that they're owned up, but it is hopefully something that happens at best once every few weeks. And at that point, it's worth checking out. The technical bucket, this is where it gets a lot harder. Because how do you look for technical commands on your, let's say your sysadmin's laptop or your engineer's laptop, right? An engineer running netstat is a normal thing on a day-to-day basis. You can't just alert off of those unique signals. What you look for are bursts of activity and kind of unique combinations. So stepping back and thinking from the attack perspective again, when you land on a laptop or you land on an endpoint, you need to do some initial recon, right? You need to learn the environment that you're in. You need to see how you want to start moving around. You want to find, credentials on the box, that sort of stuff. But the important thing to think about there is that when you land on a box as an attacker, you don't really know what you're on. And the way in which you do recon, it may overlap with a lot of commands that you expect engineers and people to run on a day-to-day basis, but not in the same way, right? So an engineer may run netstat as a one-off, but they don't follow that with, ifconfig and dmessage and running a whole bunch of other commands to learn about their environment because they know what their environment is. So you're looking for unique patterns and kind of bursts of activity. So that's how you approach kind of the technical bucket. And then for always anomalous, just what is unique across your organization all the time. I'm going to hand wave a little bit on this one, but there are certain things that attackers always do. Go look at all of your favorite paste bin dumps where someone's showing where they landed on boxes. Hopefully you have favorite paste bin dumps. And go look and see what are the patterns that overlap amongst those. And take a look at that as signals. We jokingly threw in, hi, you name A. Like that shows up in every pastebin dump you're ever gonna see. And meanwhile, you don't actually really run you name A on your own box ever. Treat that less as like, oh my God, I need to go implement that, and more as the way of thinking about what are commands people run when they've compromised a box and they're trying to show proof of that, versus what people actually run on a day-to-day basis. Okay, moving into persistence. So we talk about host level persistence and organizational level persistence. So host level persistence, really what you're looking for here is that you're looking for common patterns of persistence across like the OS. But the important thing to understand is that you're going to kind of lose this game. Setting your goal for looking for host level persistence is can I detect the completely off-the-shelf stuff? Can I force my attackers to have to customize for my environment? Great. That's pretty much as far as I can go on this, right? In the battle between like rootkit and rootkit detector, rootkit pretty much always wins. But this is somewhere where you can really hit and increase the cost for your attackers, that they have to do like full-on custom implant or rootkit development for your organization. That's a very unique cost, and that's fantastic because hopefully they can't reuse that across organizations. So I want to give a shout out to MimeFrame and the Facebook team. If you haven't read MimeFrame's talk from 2012 at RuxCon, it's a just awesome talk. It touches on some of this sort of stuff that I'm going to talk about, and then some cool AppSec stuff. It's totally worth reading. So we took some concepts out of that, and then we started scaling those out a lot. And we built what we kind of consider a host, our own kind of version of a host IDS. And we're thinking, all right, a yarn website is making their own host IDS. What would we call that? Naturally, it's TripYarn. And its whole goal is to really look for real-world patterns of both persistence and of compromise. So I wanted to go into like a few lessons here that we learned detecting actual hostile persistence mechanisms with these things. Oh, right. The other thing I was going to say was, if anyone saw like the release around Midas, so we did a joint release with Facebook of some of this stuff. It's kind of the framework that allows you to build a lot of what I'm talking about. It's kind of cool. Check it out if you'd like. It's up on GitHub. So what lessons did we learn actually building this thing and deploying it across an organization, looking and detecting real patterns of compromise? For methods of operating system level persistence and host level persistence, the first thing that you do is you find the normal OS mechanisms for persistence. How does an app start on boot normally in your target OS? Go find that, instrument it, and then start to treat additions or modifications to those sources as events. So now you start to bucket your events. If you can get like, okay, there was a modification to X, that's an event, cool. Is it a rare event or is it a frequent event? And this is kind of like the non-technical, technical bucketing of, for non-technical users, it's very easy. For rare events, it's very easy. New SSH keys landing on a host, a new cron tab being created. These are the sort of things that very rarely happen in an organization, and they're anomalous enough by themselves that it's worth checking out when it happens. Right? A new cron tab being created on someone's laptop is incredibly rare. Like 99% of the time, that's a new engineer starting on their first day setting up their box. And you can look at those alerts. And the important point here is that if you can get these things, and when I say low false positive cost is, you're never going to get rid of false positives on this sort of stuff. But if you can decrease the cost of investigating a false positive to almost nothing, you've won. Right? If this alert goes off once a month and it takes you 30 seconds to investigate, that is a cost that is totally easy to pay. If it happens every day and a dozen times a day and it's false positive every time, that's not a cost you're willing to pay. So it's very easy. Yeah, go for it.
I know Etsy uses Chef. Have you guys tied into the Chef process so that when Chef is the one doing it,
Right.
it just links back?
Yeah, good question. So for the recording, the question was Etsy uses Chef a lot, and have we tied this into Chef to look at a lot of anomalies? No. The answer is no. We use Chef very extensively in our production environment. We do not currently use it on our endpoints, and this is all for endpoint instrumentation. For server instrumentation, we'll be making use of a lot of that. But yeah, good question. Actually, just shout out questions when you have them. If you think, even beyond questions, if you think some slide is total bullshit, shout it out. Like, that's fine. Okay, so that's easy for like events that are rare because you can just alert directly off of them. But what about events that are actually quite common? And so for ones that happen all the time, you need to really use not data just from a single host, but start to aggregate data from across your entire environment and your entire organization. So an awesome example that we learned out of this was kernel module. So I want to run through this. So our goal was like, we came in one morning and we're like, okay, we want to know if an anomalous or malicious kernel module loads somewhere in our environment, like on some endpoint. We want to be able to feel like we have that capability to know if it's happening. So what we thought, our first theory was that kernel modules after boot time will load very rarely on an endpoint, right? Like once you boot up and it's done loading all your modules, great. Maybe if you're inserting like USB sticks and stuff like that, it'll load up, but otherwise pretty rare. Totally wrong. Completely 100. If we would have been like willing to bet money on this and we would have lost wildly. They happen all the time on OS X. Like kernel modules load and unload constantly. So you can't just treat that as a rare event and alert off of it. You can't obviously just whitelist and blacklist names, like that's never going to work, especially because a lot of your typical malware and things like that is going to name itself like actual OS mechanisms, right? In Windows malware, you see this all the time of something living in, Windows System 32, stuff like that. And instead, what you really want to look for here is this module organizationally unique? So the way that we broke this down was, if module X just loaded on an endpoint, did it get loaded on less than n endpoints across the organization in the last D days? And start to look for organizational uniqueness. Because even though things are happening all the time, if it's not unique, it's not interesting, right? An attacker doesn't load a kernel module across every laptop that you own in the same day or the same hour or anything like that. They pop a couple boxes at once and they persist on that, and then they move from there. So if that interesting kernel module that just popped up on one box didn't load on any other system, that's an anomaly. That's worth checking out. And this is going to kind of veer, for the next couple slides, I kind of want to veer into a tangent here, but I think it's a really important way to approach a lot of these problems, which are that from the attack side, there are really good attack techniques around post-exploitation. And you saw this in Stuxnet, and you saw this in a lot of other attacks where, or you saw the reverse in Stuxnet, and I'll get into that. For a really good attack campaign, what you want to do is separate your objectives and your tooling. Because when you get discovered, you don't want the defenders to be able to figure out exactly what you were doing just by analyzing your tool set and what you had on there. Right? If you're dropping a rootkit on some box and it has like very specific functionality as to what it does, and it cached all of its data locally before it beaconed that back and anything like that, you can figure out when you're a defender, you can figure out exactly what that attacker was after, what they took, what was compromised, all of that. If all that they've done is drop something that's in memory, that's just a CNC mechanism, that you ship it down bytecode, it executes that, does whatever that function you told it to do, and ships back the result. As a defender, when you find that, you've got nothing. You know that you were owned up, but you don't know what they took, how long they've been there, anything like that. You don't know what their objectives actually were. And it's absolutely the way to approach attack. And conversely, it's absolutely the way that we should approach defense, right? Flipping the situation around as much as you can for your endpoint instrumentation and things like that. You want the logic and you want the decisions to really be made on the server side. You want as dumb of a client as you can possibly have on the endpoints that ships data up, because when your attackers compromise those endpoints and discover these things, they shouldn't know exactly what's in place, right? So collect on the endpoints, ship it back up to the servers. And like I was saying, when attackers discover, okay, I landed on this box, I found what their kind of host IDS approach is and what they're instrumenting and all that, I don't know what they're actually looking for. What are their thresholds? What are the things that they're actually alerting on? I just know that they're collecting this data, and I know that I generated some data that went in there. Have I been detected? You don't want them to be able to see like, okay, I have a threshold set at 7 here and this thing here and this thing here, and be like, oh, cool, I didn't trigger any of that. They haven't found me, right? As much logic as you can on the server side is incredibly beneficial. And that really actually helps with deployments as well, because when you need to change thresholds and things like that, you have one central place to do it. You don't have to push this back to the entire organization. So when you're like, okay, I'm going to roll something out and I want to look for this sort of thing if it happens at a threshold of this, on the server side, I can just change that threshold. I don't have to redeploy across the entire environment. When I mentioned Stuxnet and that sort of stuff, they had to do the opposite. And the reason they had to do the opposite was they didn't have reliable command and control, right? So if you're hitting up a air-gapped network or something where you don't have reliable command and control, you have to bundle all of your objectives in your tooling. And that sucks when you get discovered, because now your defenders know exactly what you were up to. Because if you have a function called spin centrifuges really fast, it's pretty apparent that you want to spin some centrifuges pretty fast. Use that on the defensive side. Create uncertainty in the mind of your attackers. Okay, done with that tangent. back into organizational level persistence. So typically what you want to do as an attacker is, obviously, if you want to persist in an organization, persisting on just a single endpoint is incredibly unreliable, right? You're persisting on someone's laptop, they lose their laptop in a bar, and it gets wiped, right? They forget it somewhere, you lose all of your entry into that organization. What you want to do is move laterally from there, and we'll get to that, but you want to establish some sort of method of legit organizational level persistence. Typically you do that by like, okay, well, how do remote employees establish persistence? VPNs, cool. I'll go create some VPN keys, or I'll copy some VPN keys. Or kind of moving almost higher up the stack in a way, what are you actually after as an attacker? What's the data that you're after? If you're after like reading the CEO's email, don't bother with the VPN keys. Go pop their Gmail creds and go read their Gmail. Set up a mail forwarding filter on that. In terms of what you're actually after, persist that way rather than someone's laptop, and then you have to like move through the network every time. So you kind of use a mixed approach here. You do both automated kind of anomaly analysis and alerting, and then manual rollups is what we found to be kind of the most effective blend of things. So I'll give you some examples here that are in the slide. So say, for example, like new VPN key creation. That may happen all the time, so you don't do like an anomaly alert that new VPN keys were created. But what you can do is a daily roll-up and CC your security team and your help desk team who actually create the keys and say, okay, here are all the keys that were created today, and here's who they were created by. And then you set up a policy with that of like, okay, everyone needs to take 5 seconds at the end of their day and look at that email and be like, yep, those are all keys I created, or I did not create any of those keys, hit the big red button, right? And then you can also you can couple that with automatic, like just anomaly analysis, right? If your help desk people are creating VPN keys at 2 a.m. in their local time, that's not them creating VPN keys, right? Things like that from unusual locations. If your help desk who's sitting right next to you is creating a key from Kazakhstan, no offense to Kazakhstan, it's not legitimate. So let's give some examples of like instrumenting Gmail as kind of a case study on this. So what we wanted to know, and kind of our goal out of this, was how can we instrument Gmail? Because we run on Google Apps like every startup ever. Instrument Google Apps or instrument Gmail to detect the compromise of a domain admin level account. Gmail actually, this isn't super widely publicized or anything, but Gmail actually provides some interesting APIs that give you some really interesting data. So the email audit API and the admin audit API allow you to extract a lot of things that you actually really want to know about if you're using Google Apps in your organization. You can pull down a lot of logs from this, and then you store them locally so that you have a record for incident response later on, because getting logs out of Google otherwise is a thrilling experience, we'll say. And you can start to then perform alerting off of this. So you can start to look for very strong signals of compromise and then just general anomalies. So sign-ins from unusual locations and times. That sort of stuff is the kind of general anomalies that happen sometimes, but they should, again, be such a low false positive cost that you can deal with it. Right? A sign-in from Brazil happens sometimes. Your like help desk person is on vacation, and that's fine. But they're not there every week, so you investigate it once a month or something like that, and it's fine. But then the things that, and obviously that scales worse with your organizational size, right? If you're a 20,000 person organization, you have a lot of people who have this access. They go on vacation all the time, things like that. But even in much larger organizations, there are certain patterns that are just rare all the time, which is like creating new domain admin level accounts happens incredibly infrequently. That's always a strong signal to go investigate. Creation of, depending on your organization, but this one's kind of interesting, creation of new mail forwarding filters. So when I talked about when your attack objective is to read the CEO's email, you don't want to persist on their laptop and then like view their email from their laptop. You just want a copy of their email, and you don't want to go download the mailbox because then that's just historical data. You want everything going forward. So what you do is you go pop their Gmail account and you set up a new mail forwarding filter that anything new coming in goes to them still, but also sends a copy to you. So when new mail forwarding filters start getting created for your execs and your high value targets on that, that's very interesting, and that's worth the anomaly investigation. And then, of course, any change to, I say two-factor auth settings, but really any security settings. Changes to security settings should be extremely anomalous. They shouldn't happen. Hopefully, they can't even happen in a lot of ways. But changes that are anomalous and are worth checking out. And so like here's just a random screenshot of like what this sort of stuff can look like. So you can say like, okay, this IP address with this person added a group member to this group, and this is who they added. And you can start to look at this stuff and be like, the awesome thing is if you can build enough context in your alert like this, you can look at that and be like, right, that's the help desk person, that's the person who started today, that's their new team. Like, makes total sense. And things, hopefully you can build enough context in those alerts that you can just look at them and be like, yep, makes sense, totally fine. Cool. Next section, lateral movement. Street Fighter 2 fans in the house. All right. So I'm going to talk about two kind of, I mean, obviously lateral movement we could talk for a week on. I'm going to just talk about two kind of quick things. Network and systems discovery, and then actual information discovery inside your organization. These next couple slides, I think, are probably the dumbest slides in my entire deck and possibly in a lot of decks in my past, except that it actually works, and that part is hysterical to me. So using endpoint firewalls as a detection mechanism and not as a security blocking mechanism. And what I mean by that are, you know the services that are in your organization. You know that internally you use Postgres, but you don't use MySQL, and you sure don't use MS SQL or anything like that. Instrumenting your endpoints for outbound traffic from them to log and alert but not block. So I land on someone's laptop as an attacker, and I need to see like, okay, do they use like, I want to find some databases internally, but I don't know what technology they use. I'm going to do some long, slow nmap to these 3 ports of these different SQL databases, and let's find out what's out there. I think I'm going to counter timing evasions and stuff like that by being super slow and just barely doing any traffic. The thing is, you're still originating from the endpoint. If you instrument the endpoint to say, hey, I just started talking to a service that we know that we don't use internally, start firing off alerts but still allow the traffic to go on, you don't signal to your attackers that something is blocking them or anything like that, and you get actual insights into what's happening. Again, this sounds like the dumbest thing imaginable, except that it actually works. Like I said, services that are probably interesting to attackers that you know don't exist in your environment. And don't block is really the key. When you block, you signal to your attackers that something is going on. If you allow an alert, you get useful data back. Like I said, it counters no matter what sort of nmap evasions you want to do or anything like that. It doesn't matter. You still have to send traffic at some point, and when you do, it triggers an alert. Cool. Let's jump into information discovery. So, what internal systems allow attackers to achieve their goals? It's the same ones you use every day. It's like the core of your company, right? But what's interesting here, and this really goes back to the kind of command execution around technical users and things like that, is how do you find anomalous behavior in behavior where you have wide varieties of technical and non-technical people and things like that. You want to instrument these things in the way that you would other very high-value pieces of infrastructure. And you can start to look for anomalies there. Because what it really comes back to is, when I land inside an environment as an attacker, I need to learn that environment. I need to figure out what's going on, and the way in which I use that environment is radically different from the way that people inside that environment typically use it. So you can look for things like, okay, someone's reading bug tickets at 2 a.m. local time. Are they employed in somewhere that is in that time zone? Cool, that's totally legit. Are they someone that, is it someone who's in Texas and it's 3 a.m. there? That's anomalous. The usage hours ones really break down a lot around like engineers and outages and things like that. That's where you see the false positive cases for those. So you start to bucket again, and you start to say technical and non-technical out of that. If your customer support rep or your customer support's rep credentials are viewing your security bug tickets at 2 in the morning, that's interesting. That's anomalous. And then what really ties back to recon and someone who's not from your environment looking at your environment, you see bursts of activity. You see things that I may be a security engineer looking at a security ticket at 2 in the morning. I'm not looking at 200 security tickets at 2 in the morning. I'm not scraping the entire internal bug database or anything like that. I'm not looking at these other systems in a very high speed fashion. And so you start to look for these really just unique patterns of behavior. Okay, so that's it for the first section of detection and things like that. Let's talk about, this is like Big Bird making it rain. Come on, this is like the single best image ever. What are some practical things we can do as organizations to increase the attacker cost? How do we make it more expensive? So I'm gonna touch on a bunch of things really quick. Reducing trusted CAs, cheap exploitation vectors, all this sort of stuff. And then we'll be on to our final section around attack simulations. So one day we were talking about like, okay, the DigiNotar compromise, the CA compromise, where they then man in the middle Gmail and Facebook and all that sort of stuff, that totally sucks, right? How could we reduce the likelihood that something like that would happen against our organization? Because not only does it suck, but what would really suck is if we didn't use any service that used DigiNotar, right? DigiNotar as an example. Like if some CA gets popped and used a man in the middle you, that happens and that sucks, and that's a whole problem of our current system that this guy right up front can give you a way better lecture on than I can. But what would really suck is if it wasn't even a CA that you use, right? And so what we wanted to take a look at is if you remove unused CAs, what happens? And how can we do this intelligently is really the question. So it's not that you can just go through a list and be like, oh, we probably don't use that and we probably don't use that and things like that. But the problem is there'll be some edge case where you do, and then you're in almost a worse situation where if you remove something that you actually use, now you're teaching your users to click through SSL cert warnings, which is just as bad, right? Like that's bad. We very narrowly scope this to how can we remove ones that we don't use so that we can't be silently man in the middle by a compromised CA. Obviously, you could still then pop a warning and get someone to click through it, but we're trying to go for silent man in the middling. So what we did is, all right, let's instrument our network and see what we see. And so we ran this, we're still running this actually, I just pulled the numbers the other day. But we ran several months of anonymized just traffic analysis from our corporate HQ to the internet as super stupid script. Sit there, watch. If you see SSL traffic, record the SSL CA. Increment a counter for that. That's it. That's all it does. And then let's go look at the numbers. Let's run it for a while. So we ran it for 3 months. And from 3 months, we found that less than 29% of the CAs that were installed on our standard endpoint build were actually used at all, were ever seen. And the numbers drop off like insanely fast, right? Everything below 0.5% we cut out here, and that's totally the long tail of that you see like a couple times. So here's the ones we actually use. There's a blog post where we publish like everything. And so what we did there is we started doing this from some pilot systems, and we said, okay, let's remove unused CAs and see what happens. And it kind of worked on those pilot systems. Like the interesting thing to take here is that you don't do this once and then you're done, because then you have like a new employee who starts who uses some website that uses a CA that you didn't see before. This is an ongoing thing. You keep recording. When new CAs show up and suddenly they show up for like a lot of traffic and things like that, okay, cool. Let's add that back into the list. These are all our endpoints. We control them. We can push down. We don't even have to push down the certificate. We just flip the bit to reactivate it. So you keep doing that because you don't want to teach your users to click through SSL certs. Okay, next one. Java. Java is awesome. Yeah. Java is cheap, it's reliable, and it's efficient. Unfortunately, this is for attackers and not for anyone from the organizational side. Nuke it. It's awesome. So we pulled it. We pulled Java web plugins from our entire enterprise star. Essentially all of our endpoints Java's gone from. And why I say star and what I'll get to here is what we did is we actually built some jump boxes for the couple people who actually need it. So first thing you have to do is figure out which of your groups actually use Java, which is actually kind of a hard question in a lot of enterprises. And seeing like, okay, who needs it? Cool. How do we get it to them safely? And then just start removing it from everybody else. Like everyone who doesn't need it, that's great. Jump to step 3 right there, just nuke it. For the people who need it, and thankfully in our case, it was a technical group. It was our network operations group for some like internal hardware that's ancient that still manages via an applet and that sort of stuff. We built Java jump boxes for that. And the great thing is that you can use what's always kind of seen as the problem, like laziness of not patching and things like that. You use that as a weapon in that you create a jump box that someone has to go to then it has Java installed, and then they can go manage other boxes. And then everyone's lazy. They don't want to use that box to browse the internet. It's like slow and all that stuff. So you're done. Once you do your one task with it with Java, you're done after that, and you sign off. And you can actually then enforce this with policy, right? That these Java jump boxes, they can't hit the internet. You can re-image them all the time because they don't really need to cache anything at all like that. And you only have a few boxes to patch. And it doesn't matter that you take a month to patch them if you want because they can't hit the internet and you only use them for one internal task. Yeah.
Just Java in the browser or Java completely?
Good question. Explicitly Java in the browser, not Java as like a programming technology or anything like that. Java in the browser, how we're all getting owned up still to this day. Apparently Oracle just released something that actually really works with whitelisting. The earlier stuff didn't really. Yeah.
And then what do you use to enforce that people don't accidentally put it back on?
I did not pay this guy for the next couple slide lead in, but we'll lead in. So Java, not only does it reinstall, when you apply Apple security updates, it reinstalls Java. That was amazing. Like we ran like a thing once across the enterprise and we're like, cool, Java's nuked. We can all go to the beach. And then it suddenly started showing up again. And we're like, wait, those are on like really technical people's endpoints. Like they would not have installed Java. What? Oh, it was our awesome engineers who were like applying security updates the second it came out. It flipped Java back on their endpoints. It's amazing. You have to just keep nuking it all the time. In our case, like look, I got, you can't see it with this. I got graphs and shit. Like this is security updates being applied and you watch Java just show back up in the enterprise. Cron a script on everyone's laptop. Honestly, like you can just go low tech on this, nuke Java once an hour, once every 10 minutes, just wipe the shit out. It's a thrilling adventure. Okay. So next up, browser updates, right? If we can start to kill off the different plugins of how we're all getting owned up, now we're increasing cost. That's how this whole theme kind of comes together, right? If you can get rid of Java, your next target's going to be Flash. If you could get rid of Flash, your next target is probably going to be either the browsers themselves or different client-side technologies like Adobe stuff. So we wanted to next focus on browser updates. But the problem is we wanted a not heavy-handed approach to this. We didn't want to force updates. We didn't want to force reboots or anything like that because there's no quicker way to piss everyone off in your organization. And we like going drinking with people in our organization. And if you reboot their boxes all the time, they don't buy you beer, which is a critical security mechanism. So what we wanted is we're like, all right, we've got a theory on this. Like, we're going to try this out. We all think this is going to fail, but we're going to try it out. What we did is we built browser detection logic into our internal SSO point. And what we said here, and the slight tangent, but UX is really key. Like, if you want this to succeed, it's all about user experience. You show how quick it is to update, and you provide a bypass mechanism. So, in this case, you hit our internal SSO point. You're using a not quite the latest version of Mosaic, and you need to update to Netscape Navigator version 3.0. Windows for Workgroups probably in there. Otherwise, the kitten is sad. And this is another key. Include a sad kitten. It will get everything done. But the other thing, and probably the most important part of all of this, is you have one button that's like, hey, give me more info. If the two on the screenshots, you put like arrows and you say, click here, you're done. Like, that's it. That's all you have to do. There's more info if you need it, but then this is the most important part. This is the red button that says, cool, I'm in an important meeting. I don't have time for this. Let me bypass it. And what you do is, when you're rolling this out, you communicate to everyone that like that red button is a fire alarm. It's there for when you need it. And if you pull it randomly at 2 a.m., people are going to get really pissed for no reason, right? So you provide the bypass mechanism. And you say, okay, you're in an important meeting. Totally get it. Like, click through, update your browser later in the day. That's fine. But it's going to page people when you do this. And if you're doing it like 5 times in a day or 5 times in a week or something like that, someone's going to come over and be like, hey, can I help you out with something on this? Like, is there something like that's preventing you from updating? What we could not believe. So this was our theory, right? That like, hey, we're going to try this out. Do we think anyone's going to actually update, right? Was kind of the theory. It's insane. It totally worked. We couldn't believe it. New browser version comes out. Everyone's out of date. You get the dialogue. Everyone updates. You have people coming back from vacation. They update. We couldn't believe it. It totally works. It's all about communication on that and saying like, hey, I'm not just going to tell you to go update your browser because if I'm not an engineer or something like that, I don't really know what that entails. Do I have to close everything? Do I have to reboot? Like, what's going on? If you look at 2 screenshots that say, click here, you're done, that's all we're asking you to do, people do it. and you provide a thing that says, hey, here's how you bypass it if you need to because you're in an important meeting and we get that, cool. People bypass it, and then later in the day they update. All right, next one. Interesting story. People will install malware because something told them to install malware, and it happens often. Shout outs to Bonsai Buddy, if anybody remembers that. And yeah. The awesome thing out of this is that you can almost entirely kill this for free. And you do it by pushing ad blockers to the organization. You roll out ad blockers to your organization, you no longer get the malware pop-ups that say, hey, your computer's unprotected, click here to install the firewall. Because people will be very well-meaning. We had this in a case. We had someone that had like a pop-up happen, and it was like, your Mac is unprotected, click here to get a firewall. And they were like, oh, I want to be protected. I know that like we're serious about this stuff. Like, let me install that firewall. And so they installed that firewall. And thankfully, it lit up a whole bunch of fun stuff in TripYarn where we were like, what the hell is that? And went over, and this was like one of the coolest moments that we had early on in the like early TripYarn development. We went over and they were still in the installation process for the thing on their laptop. And we walked over like, hey, this is going to seem weird, but are you doing anything with the firewall? And they're like, oh yeah, I got that pop-up that like you guys sent, right, about installing it. Like, well, we'll just borrow that for 1 second and nuke everything. And it was awesome, right? And the interesting takeaway out of that was like, everyone there had the best intentions involved, right? It wasn't like, oh, I don't care, whatever, do whatever, it's my work computer, I don't care. It's like, oh, I want to be protected. How do we organizationally kill off that where someone's going to be tricked with the best intentions? If you're not getting pop-ups, you're not getting pop-ups that tell you to install firewalls. Okay, final section of this, security awareness training. Pool shark. So historically, we focused on reducing the number of people that fall for phishing. Right? We've tried to like, we do all this sweet graphing and stuff like that. Like we run an internal campaign. We're like, okay, 60% of my organization fell for phishing. Now I ran it again a month later. 50% fell for it. Awesome. I'm getting better. I'm getting better. It turns out this is a fine goal, but it's the wrong goal to focus on. It's the wrong metric to really be going after. Not to say that it's unimportant. Of course you want to reduce the number of people who fall for phishing, but it's actually the wrong way to think about the problem. Because if you're thinking about how do I reduce the number of people who fall for phishing, the assumption is that one day you'll get to zero, and that's why you're going for that. You're never going to get to zero on that. There's nothing unique about any of our organizations where you'd ever be able to get to zero. Another way to think about this is if you go from 36% on fire to 27% on fire, you're still on fire. It still sucks. What you want to be focusing on is not reducing the numbers, but increasing the numbers of people who report it. This is the metric to go after. This is what to think about. What you want is to increase the likelihood that someone's going to report it to security because someone's always going to fall for it, especially as you get like tighter and tighter spear phishing groups of they're not just spamming the entire company, they're targeting 3 people. How can I increase the likelihood that one of those 3 is going to report it to security? Because then it doesn't matter that the other 2 fell for it. You can start your IR process. If someone's like, hey, I just got this email, looks sketchy, can you guys check it out? You check it out, it's totally sketchy. You can start IR right then. And you can hopefully start IR in a matter of minutes or hours or maybe days. And of course you want to reduce the number who fall for it, but how do you provide incentives to report things? And that's really what to focus on. In our case, what we've done is we ran one campaign internally where we did some sweet phishing against the organization, and then we all pretend to be at lunch or like away from our computers and just watch the madness unfold. But the thing is, we then followed that up with, hey, everyone who reported this to us is now getting a company gift card out of this. No one's going to be named and shamed. There's going to be no embarrassment to anyone who fell for it. We're deleting the list. Like we kept the list, but to do browser analytics and things like that. No one's going to be publicly named. Oop. Yeah, that's a good one next. Shit. No one's going to be named and shamed if you fell for it, because we fall for it. In fact, we got a number of notes from like senior engineers who were like, I always read about phishing campaigns and people fall for it. I always roll my eyes. I just fell for that. That was awesome. Thank you for doing it. And if you don't embarrass those people and you actually reach out and say, awesome, thank you. Here's like a gift card for reaching out to us. You incentivize people to come talk to you. And that's the metric you want to increase. All right, final section, attack sims. Everything is better. All right, 10 minutes. I'll talk even quicker. It'll be perfect. Everything's better in a tux. All right. So the problems with pen testing are actually fairly I feel like fairly well understood in the offensive community, especially amongst pen testers and things like that, of like, this client is asking me to do this one thing. It's totally unrealistic. Like, this isn't how people attack systems and all that. Conversely, on the defensive side, it's really, pen testing ends up being, you end up doing what's really one very small subset of pen testing and treating it as if you got the value of everything. And so what I mean by that is typically what you see for like network pen tests are vulnerability enumeration, right? You run a scan, you say like, these are the boxes that need to be patched. This is what's going on over here. This one's outdated. That one's outdated. I can reach that one so your firewall isn't configured right. The problem is this doesn't give you any data as to how an attacker actually operates against your environment. It's a list of things to go patch. It's not how you're going to get owned. Right? And the interesting thing that comes out of that are oftentimes it's a lot of the lowest severity things out of there that actually lend itself to real compromise. You might have some high severity thing that's patching on this and cool, but it turns out it's really a pain in the ass to write the exploit for that one, and I'd rather just go use that other thing over here, and it's going to get me access as an attacker. What you're really looking for out of this, and this is not to say don't do those other things, continue to do those other things, but understand the value that you're getting from them. It's one area of value, and you want to get lots of value, and you want to do vulnerability enumeration for some things. You have compliance over here because it's compliance and you have to do it, and then you want other things to see how attackers actually operate against your environment. And the big takeaway here is not to show this as like a binary thing of if compromise is possible or not. It's possible, like full stop. And what you do is treat this as like scientific data. You use this data of seeing how people operate against you to start to build your defensive mechanisms. And I'm going to go all into this, but this is really the high level takeaway. This gives you the data that you need to start to make choices as to where do I build detection mechanisms? Where do I focus my instrumentation efforts? How do I focus all of my efforts here? Like I said, these complement all of your other things, but these are checklist. Like these other things are kind of your checklist. Like I need to patch these boxes. I need to meet this PCI requirement. That sort of stuff. Checklists don't attack you every day. Attackers do. So run attack simulations. The four kind of key takeaways we've learned out of running a number of these things that we kind of wish we knew when we started. Make them goal-oriented. So, okay, here's your list of a dozen goals, right? Obtain domain admin, read the CEO's email, view this credit card data, come up with goals. What are your actual attackers' goals when they're targeting your organization? Make those your goals for your attack simulations. I cannot stress this one enough. Your full organization is in scope. There's nothing more hilarious to your actual attackers than the concept of scope. They do not abide by it. The dude does not abide by scope. This is challenging, right? It's very easy to say this as an offensive person and say, of course, everything needs to be in scope. It's very challenging as a defensive person to really make this happen. And the ways that we went through this are, okay, if you're about to, let's say you found credentials for this box, or you found this internal box is running some outdated service, but it's like a production database. Here's what we want you to do. We want you to call a cutout. Not us directly, because we're actually running this with the security team blind to not influence detection. Call this cutout and say, hey, I want to look for, like, I have this box. I think I can exploit it. The exploit that I have for this lands probably 80% of the time. I would try it if I was attacking, but this is a live thing. And so what we've done in cases like that is like, okay, you know what? That's great. We're going to treat it as if your exploit landed. Here are some credentials to that box. Just SSH in and treat it as if you landed on that box and keep operating. And that's how you mitigate the risk of like knocking out a production database, but allow your simulations to continue. So have them kind of reach out and say like, okay, I've got this thing. I want to go test it out. And do that without just saying, okay, just do whatever you want, because obviously Murphy's Law, like something's gonna go down. Really simulate real patterns here. Start them. So depending on how you want to simulate compromise, start your attack team there. You want to simulate a popped laptop, start them on a standard laptop build. You want to simulate a popped web or a popped database via SQL injection, start them on prod DB or a prod web. Start them from where your attackers are going to start in the environment and go from there. Attackers should be totally encouraged to use ODays throughout the environment, however they see fit. Attackers have ODays, it turns out. And then break the simulation down into iterations. This was an interesting kind of logistical one for us. Typically, you run Typically you run like pen tests and things like that as, multi-week engagements, and it's a starting point and then it's an ending point and then you get your report. But a lot of times, a lot of the goals that you're going to give, someone's going to hit in 48 hours. Right? And if you're doing a 2-week simulation, what you want to do is then say, okay, cool, you did that goal. Let's restart and try that goal again. Maybe swap in a different attack team from the company there. Maybe just try it again and try to go a different route. Generate as much data as you possibly can. And what you really want out of this are attack chains that show your attack team went from A to B to C, and most importantly, why. Why did they go from this? And a lot of times it can be gut feeling. That's perfect. This is why you're simulating actual attackers. Say like, I want you to keep notes on why you went from this box to this box, and just as importantly, why you didn't go from this box to that box over there. Right? In our case, we were running some of these and we're like, this is awesome. We built like some really cool detection mechanism over here. We threw a great detection party and the attackers never showed up, and it sucked. Right? And they're like, oh yeah, we didn't have to go there because actually we found this other thing that gave us all the info we needed. And so we just went this way and then that way. So keep steps on why you didn't go certain ways. What you want to do is you want to simulate behaviors and patterns as much as you possibly can. And you want to vary your different attack profiles because your attackers are going to be after different things and operate differently. You're going to have your smash and grab attackers that don't care that they light up every signal in the place. As long as they get that data and they're out, cool. Like they're just going to operate as quickly as they can. And you have other ones where their goal is just to like quietly maintain persistence. They don't even want to achieve an objective against you right now. They want to have that persistence for when they want that objective 6 months from now. And those two sets of attackers operate completely differently. Simulate those different profiles. And most importantly, what overlaps between those profiles. If you have multiple profiles and things overlap between them, awesome. That's like your best bang for your buck on your detection mechanisms there. Because now you get all your different attack profiles at once. So conclusions, think about defense like an attacker. Increase cost wherever you can remove or reduce just cheap exploitation vectors. Build detection mechanisms around real attack patterns. Look at like how past compromises have happened, how like your attack simulations happen, new offensive research that's going to change the way people go after targets. And then don't be afraid of having internal product tooling and product development capabilities on your staff. In our case, it's about 1/4 of the team is spent like building out kind of custom internal tooling and things like that. And you guys are awesome. Thank you.